Hello everyone, welcome back to Let's Unbound. Yes, I am back with another episode, the fourth episode of this series, 3.4 Sine and Cosine function graphs. So, sine and cosine is very important um, things you should understand on trigonometry, right? If you understand this, then rest is fine. So, today we are going to do the important parts of sine and cosine function graphs. So pay attention, do watch the video from the beginning till the end, and of course, we will do some problem solving, important problems today. Here. So, how I will plot the points, right? For example, to draw a line, to sketch a line, you need 2 points or a slope and a point, something like that. For sine and cosine function, yes, of course, with the help of unit circle, we can completely sketch it. But now, a very simple sketching way is like you take from for one period. Sine function has a period 2 pi. After 2 pi length, it will repeat the same pattern. So I'm picking 0 to 2 pi here. Some peculiar values, like as we did in previous videos, classes. So pi by 6, pi by 4, pi by 3, these values we know. So I approximated also because irrational numbers are there. And most important values are axis values like pi by 2, y-axis positive, pi, x negative, 3 pi by 2, y-axis. So these peculiar values I pick. These peculiar values I pick here. Then you just plot them and we are going to observe how the graph is. Okay. So here, pi by 2, actually sine will start sine will start at 0. 0 comma 0. When 0 at 0, pi by 2, it will reach maximum. Okay, odd multiples of pi by 2, it will switch between maximum and minimum. So first 1 pi by 2 maximum, next 3 pi by 2, it's minimum minus 1. Okay, and what happened at pi, 2 pi, it will cross x-axis. At multiples of pi, 0 pi, 1 pi, 2 pi, 3 pi, or minus pi, multiples of pi, it will cross. So I did this. It's a smooth graph. It's not like a straight lines you are connecting. It's a smooth graph because many points are there, like pi by 6. So how it behaves is first it will increase like this, and then it will come down cross x-axis. It's decreasing from here and again decrease. After this, it will increase. This is one period, one cycle we draw. Another cycle, you can just 2 pi to 4 pi. You repeat the same pattern. Okay. So that's it, sine graph is. Now, so observe this sine graph, like it start from, it's like a two hills or a wave. Okay. Now, key features of sine graph. Sine graph y is equal to sine theta. Domain is all. I did only for 0 to 2 pi, but negatives, positives, minus infinity to plus infinity. But range, when you see maximum, it can go to minus plus 1. Minimum, it can go to minus 1. And in between all the values, it can be. So these are domain. And yes, many sine graph are possible. We are just doing a parent graph of sine theta, right? So this is enough to understand. These are key features and it's a wavy structure, right? Here also you can discuss the key features of increasing, decreasing, right? So where it's increasing, maybe here it's increasing. From here to here it's increasing. From here to here increasing. These things we can do. And where it's concave up, concave down, a point is given, you find concave up or down, everything we can do here as we did for other graphs in the same manner, right? Now, cosine graph. Yes, I listed some important values of cos theta and I approximated this, but I'm going to pick main values like 0, pi by 2, pi, 3 pi by 2 pi. That will give at most a good, decent sketch of it. So here, cosine graph, cos will start from 1. It will not start from 0. Okay, because cos 0 is 1. And I will put it here. Then pi by 2. Okay, actually sine at pi by 2, it reaches maximum minimum at odd multiples of pi by 2. Right? But pi by 2 on odd, now it's reverse. At pi, it will reaches maximum minimum, I mean cos. Okay, so it starts with maximum, then it will decrease. At pi by 2 and 3 pi by 2, it will cross x-axis and it will be like this. right? And then it will decrease again. At pi, it will reach the lowest. Okay. Then it will increase. Then only it can cross x-axis. Then again it will increase and reach the second maximum. It starts with maximum, ends with maximum. When you see sine, it starts with 0, ends with 0. Okay. And that's it. This is how the cos graph will look like. But when you continue this, the same pattern, it will look like a wavy structure. Okay, I did for 0 to 2 pi, one cycle. We can just extend on both sides, the negative side and positive side. Key features, y equal to cos theta, domain, all numbers, any angle you can give negative, positive. Range is -1 to 1. Here also maximum is +1, minimum is -1. If you see something like cos theta is 2, it's impossible. Okay, right. Cos theta cannot be 2. Now, let's solve some questions. For each interval, state whether f of theta equal to sine theta, f is concave up or concave down on the interval, and also state whether it's increasing or decreasing on the interval. So we already did a sketch. So let's draw, then it will be good, right? So 0, pi by 2, pi, 3 pi by 2, and 2 pi. Okay, this is 1, this is -1. So 0, and it will reach the maximum here. Then it will cross, it will reach minimum and something like this. So 0 to pi by 2, let's say increasing or decreasing. It's increasing, of course, 0 to 1. So it's increasing. Then it's concave up or down. It's facing downwards. Okay, actually it's something like this. It's facing downwards. So it's concave down. Then pi by 2 to theta, pi by 2 to pi, it's decreasing, dropping down. So decreasing, but still it's concave down. Okay. After pi, pi to 3 pi by 2, actually this is maximum. Let me put it like this. Okay. This is the minimum, I mean. Pi to 3 pi by 2, it's decreasing. It's going low. Y value is getting lesser. So decreasing and concave up in this case. Okay. It's decreasing but concave up. And 3 pi by 2 to 2 pi, it's increasing but concave up. Okay. That's simple with sine and cosine graph. Even if it's for cosine given, you just go with a simple sketch for that interval and you can do all the test. Now, question number 2. For the function f of theta is cos theta, what are the values of the domain f of theta is minus half? Okay, so f of theta means what? Cos theta. So we got cos theta equal to minus half. Ignore the sign. So recall the reference angle. Okay, so cos theta equal to half means this implies theta is pi by 3. Okay, we did in many problems in multiples of pi by 3, right? So theta is pi by 3. This is just reference, not your final angle. And I should solve for theta. F of theta equal to number means I'm solving for theta. Domain is theta, right? And it's negative. Cos theta will be negative at second quadrant and third quadrant. Here it's all are positive. Here cos is positive. So here positive. I am looking for second. With your reference angle, how can you write an angle in second quadrant? It's pi minus theta, and third quadrant angle will be written in the form pi plus theta. Okay, so it's lie on quadrant 1 and 2. 2 and 3. So quadrant 2 angle, how will you write? Pi minus theta reference angle. So pi minus pi by 3, and if you simplify, it's 2 pi by 3. Now, in third quadrant, also cos is negative. That will be pi plus reference angle, pi plus pi by 3, and you will get 4 pi by 3. Right? Okay, done. Next is, this is just for one rotation. But you know what? For theta, it's like minus infinity to infinity. I'm just telling one set of solution. I need to generalize it. So generally, Same thing after rotation. So you do 2 pi by 3 and again you do, with that you do 1 rotation. That will be the answer. 2 rotation you did, that will be. So how can I generalize it? Just uh, after a period. So add a period and put an n. 2 pi n. N belongs to z, whether it's positive or negative, this will hold. Okay, general solution. Not only this, or 4 pi by 3 plus 2 and 2 pi n. Your period times n and n is z. N belongs to z. Okay, so don't stop here. You should extend. They didn't mention, okay, find the solution in this particular interval. So if it's a general question, give the general solution. Right. And moving to last question. For the function f of theta sine theta, what are the values of the domain f of theta is 0? So like from our previous graph, we can see sine will cross x-axis at 0, pi, 2 pi, like that. Okay, at multiples of pi. So 0, here it crosses at pi, it crosses at 2 pi, it crosses at minus pi, at minus 2 pi. So multiples of pi. So this is a very simple solution. And just recall when sine theta will be 0. Sine theta was 0 when your theta is 0 plus or minus pi plus or minus 2 pi. Whenever it's a multiple of pi. 3 pi and so on. So generally you can write theta is equal to n pi and your n belongs to z. In that way I generalized it. Sine theta will be 0. And when theta is n pi. So that's simple it is. And yes, I have a bonus question for you. We are given an angle theta in standard question. The function h of a equal to cos a for another angle alpha, theta less than alpha less than 2 pi. Which of the following is true? H of alpha. H of alpha is cos alpha. Your alpha is between theta and pi. This is theta. So your alpha is somewhere over here. Okay. So you check which will be the correct option. Okay, you have to compare. Very simple, no working out, just apply your reasoning skill. And that's it. So you can comment your answer in the chat section. And that's it. Here we are at the final part. Of course, scan your QR code if you want to join Let's Unbound student community. And with this, I'm wrapping up here. I will be coming back with fifth episode. Until then, keep learning, keep practicing, and stay curious.